Okay, if you are given a diagram like this, and then we are required to calculate the acceleration and the tension, you just have to separate it like this. As you can see, write the free body diagram of this diagram. You write the free body diagram of this one, and then leave this one. Here we have frictional force, you have tension, and then you write it the F net, and then after you write the equation. After writing the equation, substitute. After substituting, then you check what is missing there, and then you equate to, you arrange it in such a way that it will be simpler when you substitute to the next equation. Say equation 1, and then you go and start with this one as well. When you start with this one, you're going to write the same thing. Draw the free body diagram. The free body diagram, it helps you to derive the equation, and then after write F net, and then you write the forces that are active on this diagram. Substitute the values. After substituting the values, then you arrange it in such a way, grouping the like terms in such a way that it will be simple when we are going to substitute to the other equation. And then let's see. So let's say, for instance, we are given this question. So as you can see, this question is the same as this one. This is the diagram for this one. So here you can read the statement and check what is given, what is not given there, and then what we are required to do is to calculate the acceleration and the tension. So what you do, first of all, you write what is given. Looking at this diagram, you write the mass. So you're going to use this mass, you don't jump to the other mass. And then you use this frictional force, and then you draw the equation that acts here. Then write F net. F net represent all the forces that act on this diagram. And then after writing the F net, write tension here, because your free body diagram, I have to show you these forces. So you're going to have a force for frictional force, a force for tensional force, and then go to MA. And then you're going to substitute this one. Substituting 20 because your frictional force is 20, and then substituting the M because your mass is 5. Then you're going to take 20 to the other side, and then make T the subject of the formula. Then you call this equation 1. So because you see you don't have T, you don't have A, you still need another equation. So you're going to start with this one, write the data here for this one. So you're going to concentrate on this one. So the forces that act here, you have this one for tension, frictional force, and the applied force. Then you can draw the free body diagram like that, and then from there you have mass for 20, that is 10 kg, and then you have frictional force, then applied force, and then you can write F net for this one. And after writing F net, you write the forces. The forces that is leading is this one. This was the bigger force. These are the opposing this applied force. Anything that opposes the applied force become negative. Just put negative tension and negative frictional force. You are going to substitute 130, and then you're going to substitute the frictional force. The tension, you don't have it, you're going to substitute 10 here on the next step. So as you can see, there's a 130 for applied force, and then for frictional force for this one for body 2, and then the 10 for this one. And then after, you're going to take the like term, the 130 and this one are like term, you group them together, and then you subtract them. As you can see, this one is negative, so you're going to get and then after, you're going to take the 95 to the other side. When you take to the other side, you change the sign. After taking to the other side, you have to get rid of this negative. So to get rid of this negative, you have to divide by a negative sign, -1 both sides. And then after, you equate to this equation, taking the negative out, you're going to have this one. So you have this and this one. So you're going to equate these two equations. equation 1 equals to equation 2, you're going to take this one, you put it aside. This is equation 2, you're going to put it the other side of the equation 2, then you group the like terms, and then after grouping the like terms, solve for a. This is equation 1, as you can see from here. Then this is equation 2, as you can see it from here. And then you're going to group the like term, the one that has a, so you can see minus 10. When you take minus 10 to the other side, it becomes positive, as you can see from here. And then when you take 20 to the other side, it becomes negative. So you're going to add this one, you're going to get 15, and this side you're going to get 75. There is 15 from this side. And then you're going to get rid of the 15 here by dividing both sides by 15. Dividing both sides by 15, you're going to get a this side, and then you're going to get 3. Then it's 3 meters per second, and then it's your acceleration. Because you have acceleration now, you can substitute acceleration represented by a. You can substitute the value of acceleration, or you can use this one. And then you're going to take 3 and put it here. So you can solve for calculate the value of t when a is this one in equation 1. So this is equation 1. You're going to take this one, substitute it here, and this is the equation 1, and then take 3, substitute with this a, and then 5 times 3, it's 15, plus 20, it's 35. So this is how you will calculate the tension. So that's how you will answer it, and we'll see on the other ones examples.